Hi everyone, in this video I'd like to talk about exploring tension on two wires and a weight that is suspended. So we've got a diagram shown here, and basically we've got a force on wire 1, I'll call that F1, and notice I have a little arrow over the top of that to designate it's a vector. So vectors are things that have magnitude and direction, and the little arrow over the top of the symbol means I've got a vector. So I've got force on wire 1, designated by F1, and it has a magnitude of 39 newtons. So right away, I can write down some information that the magnitude of vector for force 1 is 39 newtons, and I designate the magnitude by those vertical bars. Next, we're given that the force on wire 2 is unknown. So I'm just going to designate that the force or the magnitude of force on wire 2. We don't know what that is. I'll put a question mark. And the weight of 55 newtons, that's this little box here, it's being suspended. And that means it's not moving up or down or left or right. So everything is equilibrium. In other words, the force is pulling to the left and the right horizontally sum up to 0, so that there's no net force dragging it to the left or the right. And similarly, in the up and down, the vertical direction, the sum of the forces in the vertical direction equals 0, and hence there's no movement. So what I can do here is I can start to write down some information about these vectors. So vector F1, I'll use the angled bracket notation. If I want to represent that vector, I know the magnitude is 39. And for the horizontal component, it's going to be cosine of whatever the angle is. So let's take a look at the angle. If I look down here, and I draw a vertical line and a horizontal, notice that alpha is in the upper left-hand corner of this triangle, and I've got a pink line here and the dotted line. Those are parallel lines, and these are alternating angles. If you remember from high school geometry, those are going to be equal. Those are both going to be alpha. In other words, the reference angle for this vector, if I drop a perpendicular down to the horizontal x-axis, that angle is going to be alpha. Now, the other way you could get there is you could say, okay, we've got alpha, I've got a right angle there, and then this angle is 90 minus alpha, and therefore the other complementary angle there would be alpha. Any way you get there, we've got force 1 represented by angle bracket 39 times cosine of alpha. And the vertical component would be 39 the vertical component would be 39 sine alpha. And I'll close the angled bracket. And then for vector F2, I'm going to use the angled brackets. I don't know what the magnitude is, so I will just use the vertical bars of F2 to represent the magnitude of F2 times cosine of 63 degrees. And again, I'm using the same reasoning here of these alternating angles. That's going to be 63, or you could reason it out. Let's see, 63 degrees, this one's 90, and therefore, since all the angles sum to 180, you could figure out that this must be 27, and then the complementary angle of 27 is 63. Oh, that's a lot. Anyway you get there, the angle is going to be 63. That's the direction of our vector for force 2. And I will keep on going here. So the vertical component would be the magnitude times sine of 63 degrees. And the last thing that we have to worry about here is the weight. So I'll designate that with a W. This weight is being suspended. It's not moving or anything, but this weight itself is exerting force, has nothing going on in the horizontal component, but it's got a vertical component of negative 50 5 newtons. Okay, so that's the information we know. Now, since this is an equilibrium, nothing's going left or right or nothing's going up and down, we know that the sum of force 1 and force 2 must be equal to 0.55. So ultimately, this is going to give us a system of equations. And before I get into all of those details, I just want to talk a little bit about the logic here. So if I equate the horizontal components, I've got, I'll just label it horizontal. In the horizontal components, I've got 39 cosine of alpha plus the magnitude of F2 cosine 63. That has to equal 0. Why is that true? Because the horizontal components of these two wires have to balance each other, otherwise the weight would be moving to the left or to the right. And similarly, in the vertical direction, the 55 is going down, and so these two vectors, their vertical components must sum to a 55 going up. In other words, it must be the case that 39 sine of alpha plus the magnitude of F2 sine of 63 must balance out or counteract that 55 in the downward direction. In other words, these two wires must have an up pull of 55. So at this point, we have two equations in two unknown variables. So my recommendation would be to solve one of these equations for the magnitude of F2 and then substitute that in the other equation. So one way to do that, I'll take the top equation here, and if I'm going to solve for the magnitude of F2, I will move the 39 cosine alpha over to the other side. So I'll have the magnitude of F2 times cosine 63 equals negative 39 cosine alpha. And then I will divide both sides by the cosine 63. And so that quantity is then what I'll need to go and substitute in to my bottom equation.